All right, welcome. This video is CCBYNC. Glad you're here. This is the first part in the two-part. I broke this down into two separate videos. And we're going to be talking about inverse trigonometric functions today. Inverse trigonometric functions are exactly the opposite of the trig functions. If you remember inverse functions, they kind of cancel each other out just in general. So f of x of f inverse of x is just x is the idea here. And with trigonometry, that gets a little bit tricky because, well, we'll get to that. So we'll start here. Sine of pi over 4. Here's pi over 4. Sine is the y, so that's root 2 over 2. And there's only one answer to that. It's just root 2 over 2. However, if we have an equation, sine of x equals root 2 over 2, we have more than one answer because sine is positive in quadrants 1 and in quadrant 2. So what angles are going to work for this? X is going to be, as I just showed you, positive root 2 over 2 is pi over 4. Positive root 2 over 2 is 3 pi over 4. When it comes to inverse functions, this is not good. So we're going to need to restrict the angles that we're going to be using because we need to make this into what's called a 1-to-1 function. And what that means is each x value gets mapped to exactly one y value and vice versa. Each y value is mapped exactly to one x value. Sometimes 1-to-1 is abbreviated 1-1. And let's talk unit circle just a little bit when we're looking at this. Now, if we look at sine, and we'll write that here, y equals sine x. Well, sine represents y, right? This y is different. So here's our y. And all this needs to be covered from negative 1 to 1. And that means that we are here pi over 2, and here, negative pi over 2. So when it comes to x equals inverse sine of y, and by the way, this x is an angle for both. And this means that x is going to be from negative pi over 2 to pi over 2. So the x is restricted, meaning the output of an inverse function is restricted here. For cosine, cosine is represented with the x, negative 1 to 1, which means we're going to be covering pi over 2 and all the way to pi. So the restrictions in this case are going to be from 0 to pi. Tangent, if you recall, tangent of theta is y over x. So what I'm going to do is I'm going to lock x at 1. Here's x equals 1. This is the line x equals 1. It's a vertical line, right? Which means the y value is the tangent because now y is tangent because I've locked x at 1. And what this is going to do is allow me to go, you can see it's getting longer and longer and longer, to cover every value. As we do this, this is going to allow us to go from it's actually going to be the same as sine, from negative pi over 2 to pi over 2. Oh, important thing is that it cannot equal pi over 2 or negative pi over 2. It's asymptotic. So, and we know that the asymptotes, again, are at negative pi over 2 and pi over 2. Right, so I erased that there. Negative pi over 2 and pi over 2 can't exist. Do you see that as this gets longer and longer and longer, y is going off to infinity and x is becoming 0. And so neither of those exist. All right, now we need to keep an eye on these boundaries here. It's going to matter. And the difference between sine and tangent, of course, is that pi over 2 and negative pi over 2 can't exist with the sine. So what this means is when we do inverse sine, my values have to be between negative pi over 2 and positive pi over 2. So when I look here at inverse sine of negative root 2 over 2, I know that's going to be in quadrant 4. It'll have to be. And because it's negative specifically. Now, where does sine equal negative root 2 over 2? Well, negative root 2 over 2 at 5 pi over 4, but we can only be in quadrants 1 and 2. And so here's negative root 2 over 2. However, here's the problem. 7 pi over 4 is not between negative pi over 2 and pi over 2. So what we need to do is instead of going around to 7 pi over 4, I need to go negative to negative pi over 4. Inverse tangent, again, we are going to be in quadrant 4. And where is tangent negative? Tangent is negative in quadrant 4 and in quadrant 2. So I'm either at here or here. And because we know we're in quadrant 4, we're here. Now, again, here's the problem. I could go all the way around to 5 pi over 3. However, 5 pi over 3 is not between negative pi over 4 and pi over 4. So what I can do is I can go a negative pi over 3. Inverse cosine. A cosine is positive in quadrant 1 and in quadrant 4. However, cosine only exists in quadrants 1 and 2. So we're definitely going to be in quadrant 1. Where is cosine, or the x, positive 1/2? Right here at pi over 3. Inverse tangent is positive in quadrant 1. It's actually positive in quadrant 3 as well, but it only exists in quadrants 1 and 4. So where's tangent root 3 over 3? We're here at this angle, pi over 6. I know it's a lot to keep track of, but this is really going to help. All right, so inverse sine is some arc sine. You'll see it written either way as we do this. And I want us to really keep an eye on this as we're doing this. The x in this case, and once again, inverse sine of x, they cancel each other out. They completely collapse out. However, these x's are angles. Which means we're bounded between negative pi over 2 and pi over 2. Now, these x values are not angles. These are just values. Meaning this x can be between negative 1 and 1. It's important we understand the differences here. Of which type? Is it inverse sine of x? That means that the x are angles. Or is it sine of inverse sine of x? Which means that they're not angles, they're values between negative 1 and 1. So let's take a look at this. So arc sine of sine, so we're up here. So x in this case is an angle. Now our angle needs to be between negative pi over 2 and pi over 2, and I'm going to notice that 17 pi over 11 is not between negative pi over 2 and pi over 2. So what I'm going to do is I'm going to subtract, and I'm going to show you a little trick here. I'm going to take 17 divided by 11, and I'm going to subtract 2 from that, meaning 17 pi over 11 minus 2 pi. I'll put the pi's in later. And then I'm going to convert it to a fraction. Much better. So this means that my answer, negative 5 pi over 11, is between negative pi over 2 and pi over 2. So even though I said they cancel, we have to be really careful as we're looking at this. That was A. Let's take a look at B. Go B over here. B is this type, where we have sine of inverse sine. Well, very nicely, we would be able to just cancel that out. However, this number here is not between negative 1 and 1. So this one does not exist. C. Now we can look here at this angle, negative pi over 3, that is between negative pi over 2 and pi over 2. So these literally cancel each other out. And you need a separate one there. We like that. Let's try cosine. Remember cosine? To be clear, let's do this again. These x's are angles. Between 0 and pi. The positive ones will be between 0 and pi over 2. The negatives will be negative values, I should say, will be between pi over 2 and pi. So these are values here. Where once again, this x is between negative 1 and 1. And we're looking here, negative 2 pi over 3. Now that's a problem because that's not between 0 and pi. What I can do though is realize, and let me draw this. So part A, let me draw this just real quick. That this angle here, negative 2 pi over 3, quadrant 2 is regular 2 pi over 3. So negative 2 pi over 3, and this is just 2 pi over 3. And that's what I'm looking for. So what's the answer for part A? Positive 2 pi over 3, because it's in quadrant 2. Now, cosine of inverse cosine of 45, that is no problem. That is just 0.45. So that's the red type here. And 0.45 is between negative 1 and 1. So the answer is 0.45. Let's do this again with tangent. Once again, these x's are angles that are specifically between negative pi over 2 and pi over 2, and there's no equals. It's just less than and less than. Now these values are just values. And those values go from negative infinity to infinity. And again, there's no equals with that. Just less than and less than. All right, let's start with part A. arctan of the tangent of 11 pi over 6. Now we have a problem. 11 pi over 6 is not between negative pi over 2 and pi over 2. But 11 pi over 6, which is all the way to here, so going all the way around to here, or negative pi over 6. And that's going to get me in quadrant 4 between negative pi over 2 and pi over 2. So this is going to be negative pi over 6. And the tangent of the inverse tangent of negative root 3 over 3, very nicely, it's just negative root 3 over 3. Because those x values can be from negative infinity to infinity, no problem.